Algebraic Reasoning, Chapter 1.6, Exercises 13 through 24. This video lesson is a follow-up to the one I did earlier that had to do with quadratic, determining quadratic functions. And here in exercises, questions 13, 16, the data sets shown in the tables represent quadratic functions. Use finite differences to determine f of 0, the values of a, b, and c, and then write the function in standard form. So we're going to go about the process of using first and second differences, and then also the equations to determine a, b, and c, and so forth. What you're looking for is, first of all, this value here, this question mark. When x is 0, what is y? Well, that's going to be our y-intercept. So we're going to have to do some deductive reasoning to figure out what that is. In the exercise set 1 through 12, whose video I earlier recorded, this y-intercept was already given, or the c value. Now, it says write the function in standard form. Well, what is standard form? It's going to be f of x equals ax squared plus bx plus c. Okay, so we need to find a, b, and c, and then we will have our function in standard form. Well, what we're going to do is go and determine first our first differences, and from 5 minus negative 1 is going to be plus 6. Then we have 13 minus 5 is going to be plus 8. And then we have 23 minus 13 is plus 10. So these are our first differences, and they are not the same. This is not a linear function. So let's just go ahead. I'm going to just write this thing down below. First differences. DIFF. Okay, next we're going to go to second differences. And if second differences are the same, that's how we can tell definitively we have a quadratic function. Well, 8 minus 6 is going to be plus 2, and then 10 minus 8 is plus 2. So already we can do one of the ABCs, and what that is our second difference is equal to 2a. So in this case, we found our second difference to be 2, so 2 is equal to 2a. And so if we solve for a divided by 2, we have a is equal to 1. So we'll just put here a equals 1. We already determined that. And let me label here also the second differences right here. Second difference, okay? Next, we're going to work backwards to find out what this thing is here, right? Our y-intercept, or value c. So if we say plus 2, so what plus 2 is going to give us 6? Well, it's going to be plus 4. So 4 goes here. So 4 is going to be our first difference. And so we take negative 1 minus 4. So our c is going to be negative 1 minus 4. And so c equals negative 1 minus 4, which equals negative 5. And then if we put negative 5 in here, let's say negative 5, it's going to go right here. Negative 5 plus 4 should give us negative 1, and that would make everything whole. So now we have A and C. Now we need to get B. In B, okay, I'll just write down the situation here. Okay, the first difference between y values for x equals 1 and x equals 0 is equal to a plus b. So in this case, our first difference is going to be 4, which we had to determine. So we say 4 is equal to a plus b, and we already determined up here that a is 1, so we say 4 equals 1 plus b. If we subtract 1 from both sides, we get b is equal to 3. So I'm going to put up here b is equal to 3. So now we can write our function in standard form. It's going to be f of x is equal to 1, right? A is 1, so we'll say x squared. And we have b is 3, so plus 3x. And then c is negative 5, so we'll say minus 5. So this is going to be our equation in standard form. Okay, let's just go ahead and box that in. All right, that is our answer, number 13. Let's go over the next odd number problem, which is 15. There we go. Same thing. We do not have our y-intercept or c. Let's go ahead and find our first differences. Well, we have between what negative 9 plus what equals negative 8. Well, that's going to be, you can say negative 8 minus negative 9 is going to be plus 1. And then we go ahead and say, okay, negative 1 minus negative 8, or the difference between those two is going to be plus 7. And then finally, 12 minus negative 1 is going to be plus 13. Okay, again, these are the first differences. And then now we go to second differences. 7 minus 1 is going to be plus 6. This other one better be plus 6. 13 minus 7 is plus 6. So again, let me just make this note here. Second difference. So again, like we did earlier, we said second difference equals 2a. So therefore 6 in this case equals 2a. So divide by 2, we have a is equal to 3. So I'm just going to put it up here. A is equal to 3. Next, we're going to work backwards and try to find what our question mark is. So that second difference is going to be plus 6. So what we're going to do is take that 1 minus 6, and we're going to get negative 5. And negative 5 is in our first difference row. Okay. So what plus negative 5 equals negative 9? Well, that's going to be negative 4, right? So negative 4 plus negative 5, you're going to go down, you're going to get negative 9. So we'll say that C is equal to negative 4. Okay, and like in problem 13, we say the first differences between the y values for x equals 0, I'll just write it here again. First differences between y values for x equals 1 and x equals 0 is equal sign. Is a plus b. Okay, so now we see the first difference is going to be -5. So we'll say -5 is equal to a plus b. And a we already determined as 3, so -5 equals 3 plus b. And then if we solve for b, we can subtract 3. And so -5 minus 3 is going to be -8. So we have up here b is equal to -8. So our equation is going to be f of x equals ax squared, and a being 3. So we have 3x squared. And b is -8, so we have minus 8x. And c is -4, so we have -4. So this will be our answer for number 15. Okay, next. Okay. I'm making a video right now. I'm making a video. Yeah, I'll be with you when I'm finished here in a bit. Okay, toothpicks were used to create the pattern below. So you have input of 1. So our area of this shape here is going to be 1. Our area of this other shape with 2 pigs is going to be 4. You see 4, and then for this one here, we have 9. So what that's going to look like is 1, 4, 9. And so, okay, our first difference is going to be plus 3. And our second difference is plus 5. And between 3 and 5, we have plus 2. And so we have our second difference. It should be pretty apparent what this is, but we're going to go through the motions. So second difference equals 2a. So 2 equals 2a. So we divide by 2. So a is equal to 1. So a is equal to 1. Okay, and now for c, we're going to go backwards from this second difference, right, of 2. So what we're going to have to do is we're going to have to take 1. Okay, so our second difference here was we had 3, 5. So what plus 3, what plus 2 equals 3? It's going to be plus 1. So that's going to be our first difference. And now to get to our y-intercept, we should take 1 minus 1. So with x equals 0, we have y equals 0. So in this case, c is going to be equal to 0. And then we have the last one. We say the difference between the first difference there. So we're going to say f of 1 minus f using function notation is going to be 1 minus 0, 1. So 1 is equal to a plus b. And we determined already that a is 1. So 1 equals 1 plus b. And solving, b is going to be equal to 0. So we have b equals 0. So write the function relating values. That's going to be y, not given f of x form, y equals 1 x squared plus b x, and b is 0, so that's 0, plus c. That's going to be 0 also. This is going to be our function. So there we have that. I'm going to let the viewer just go ahead on this 17 through 22. I'm going to the last section here, which questions 23 to 24 for the situation below. Essentially, you're experimenting by dropping an object from a height of 150 feet from the different, near the surface of the different planets, Venus, Earth, and Mars. And what I'm going to do in this instance is just use Venus. So 23, I'm just going to do for Venus, 24 for Venus. So determine what each function represents. Now, you know what section of the course we're in, right? Working on quadratic functions. So it'd be highly suspect if this is not a quadratic function. So we say x, I'm going to just write over here on the right just to make it more accessible. So 0, 0, 1, 14.8, 2 is 59.2, and 3 is 133.2. So now we're going to take our first differences here. We have plus 14.8. We have our next first difference. We're going to have 59.2 minus 14.8. I'm going to work that down below here. 59.2 minus 14.8. So if we borrow that 1 from that 9 and make that 8, we're going to have 12 minus 8, so we have 0.4. 8 minus 4 is 4, and 5 minus 1 is 4. So we have 44.4. And then our last first difference is going to be 133.2 minus 59.2. And so that's going to be 0. And then this 13 is going to be 12. So we borrowed that, so that's 13. 4. 12 minus 5, that's going to be 7. So we're going to have 74. And so we can do our second differences. 44.4 minus 14.8. Okay, that's going to be, make that 14. We're going to change this to, that's going to be, we borrow 1 from here. So you're going to get essentially, we make that 13, right? So we have 9 here. 14 minus 8 would be 6. And then we borrowed from this 3, borrowed from this, well, we would have 29.6. That'd be right. Yeah, it should be right. So 29.6. Okay, the last one we have is going to be 74 minus 44.4. And so we're going to get, again, 29.6. So 29.6 is our second difference. And it says, do we have quadratic? Yes. The term is quadratic, so yes. And how do we know that? Because our second difference in each case is 29.6. So 29.6, which our second difference, is going to be equal to 2a. If we divide by 2, we get a is equal to 29.6 divided by 2, which is going to be 14.8. So that's a. C is 0 because we have a y-intercept of 0, so C equals 0. And lastly, for our first difference between the two, we're going to have 14.8. So we have 14.8 equals A plus B. And we already determined that our A is 14.8. So 14.8 is equal to 14.8 plus B. So therefore B is equal to 0. So our function, and I'm kind of running out of room here, our function for Venus, I'm just going to say here, for Venus, we say y is equal to a, which is 14.8 x squared. So that's going to be our Venus. And so you'll just try the same type of procedure to find our equation for Earth and for Mars. Good luck, as in all cases, and thanks for viewing.